Alrighty, hello, my name is Daniel Lunsford, and this is my Physics2212 Lab3 Magnetic Field of a Bar Magnet lab report. So for the introduction, the purpose and description of this lab was to observe and understand magnetic fields through a visual representation, as well as an elementary physical representation, to visually observe the relationship between the distance between magnetic fields, and to use the distance dependence of magnetic fields in the Biot-Savart law to find the magnetic moment of a bar magnet. Some of the fundamental concepts were modeling a magnetic dipole with a bar magnet, the Biot-Savart law, distance-dependent formula of a bar magnet, and some of the results I found were that mu was equal to 2.21 amps per meter squared, and my n value was negative 2.5. So for the models and assumptions, we assumed the bar magnet acted as a magnetic dipole in order to apply the Biot-Savart law. This is a little visual representation of that. Then for the experiment, the system was the bar magnet and magnetometer, and the surroundings were the environment, pretty much. So for the initial conditions, the bar magnet and magnetometer on the phone, and then some of the details were first, the location of the magnetometer and the phone was recorded by sliding the phone perpendicularly to the ruler vertically and horizontally, with the bar magnet on one end of the ruler in order to see at which position of the phone relative to the magnet the strongest magnetic field was being read. And some more details. Then the on-axis distance from the bar magnet to the magnetometer was found using the ruler for several different magnetic field values. These values were then plugged into Excel. Here's my Excel work, and then linearized by taking the natural log of each side and then graphed using that same Excel spreadsheet. So experiment continued. Lastly, the off-axis magnetic field of the bar magnet was found using Excel. Here are my values and some of the observations made. When the phone and magnetometer were far away from the magnet, it measures a near zero magnetic field in the x-axis direction, and then as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases, and then the correct positioning of the phone ensures that the magnetic field of the Earth doesn't really interfere with the readings for the magnetic field of the bar magnet. And then here are some of the calculations using Biot-Savart law to find mu and my n value, or the slope of the linearized data. And here's my glow script model. So B perp 3, B perp 4, my D, and then my B at 45 degrees, which is the vector at the bottom. Some of my constants. Here's the rest of it. And then here's some more glow script model calculations. The theoretical off-axis field was 2.70 times 10 to the negative 5 Teslas, and the experimental off-axis field was 6.36 times 10 to the negative 5 Teslas, so roughly an 80% difference. Sorry. And then here's some of the discussion. So for model discrepancies, a bar magnet's magnetic field closely resembles that of a dipole, so our choice of sort of modeling it as a dipole produced accurate results likely under these assumptions. And then for sources of error, the phone's location on the rulers may not have been precise, throwing off those results. And then initializing the magnetometer app to take into account Earth's magnetic field may not have been perfect, throwing off the readings coming from the app. And then for the discussion questions, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your mirror stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The results wouldn't have been accurate, as the magnetic field of Earth would interfere with the magnetometer, throwing off the readings from it. And then what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The measurements would have likely doubled because of the doubling of the magnets and the magnetic field vectors at each location. However, the direction would have likely stayed the same. Then for conclusions, the Biot-Savart law and distance dependence can be used to accurately calculate the magnetic field of a bar magnet. Dipoles and magnetic fields due to bar magnets are eerily similar, and then the Earth's magnetic field can play a large role in determining the direction of the magnetic field of much smaller objects. Alrighty, thank you.